Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 13.4, Problem 8. This is Section 13.4. It's problem number 8. It says, draw the graph of the following function. Be sure to label the x and y coordinates of any critical points. And our function is f of x equals 7x squared. So, step 1 of 7 steps altogether is take the first derivative, and I'm going to have f prime of x equals 14x to the first power. And again, where that comes from is the exponent of 2 comes down times the number in front of 7. 2 times 7 is my 14. And then x to the 1 less power, the second power drops down to a first power. So, step 2 is set it equal to 0. 14x equals 0. Step 3, solve for x. I'm going to divide away the 14. X equals 0 over 14, which reduces pretty nicely to 0. So x is 0. So I do have some type of a critical point, or a point with a horizontal tangent line, when x is 0. But now where's the height? Am I over 0 up 4, over 0 down 2, over 0 up 7? So take my x value that I got at step 3, plug it back into f of x, and find the height that goes with it. So I'll have f of 0 equals 7 times x squared becomes 7 times 0 squared, which is also 0. So my critical point occurs at 0, 0. 0 for x, 0 for y. So the next step, step 5, is plot that on a graph. So if I go over 0 up 0, I'm right on the origin. Now what I want to do is see if that critical point represents a maximum or a minimum. Does my graph go up, 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 flatten out here and come back down? Or does my graph go down, 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 flatten up and go up, up, up? So to determine that, I'm going to plug in an x value on either side of my critical point. I can use -1, +1, and see if the heights are a little above or a little below my critical value. So let's start with -1, put into f of x. So f of -1 becomes 7x squared becomes 7 times -1 squared. Pay attention to the signs. -1 squared, -1 times -1 is +1, times the 7 in front would be +7. So if I put in a -1 for x, the y that comes out is +7. So it's up here. So try a value a little on the other side, put in a +1, and see if the height also comes out up here, which it probably will. And you'll see that it does, actually. So f of +1, the 7x squared becomes 7 times 1 squared. So again, 1 squared, 1 times 1 is 1, times the 7 in front gives me 7 also. So if I put in a 1 for x, I also get out a +7 for y. And now the final step, step 7 actually, you connect these dots. So my function does come down, flatten out, go back up, 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 and it'll go up forever on either end.